Okay, so this video is a follow-up to my video on finding the slope of secant and tangent lines at specific points. This one is about finding the slope of a tangent line at any point, generalizing that process. So let's go ahead with the generalization. The first thing we're going to do is we're going to choose a specific x value, but we're going to make it general by just calling it C. And then this ordered pair here, this ordered pair would actually be C comma F of C. So that's going to be the point of tangency. Point of tangency. So that's the point where I want to calculate the slope of the tangent line. All right. And because what the function is, that point is can actually be written as C comma C squared, because the f of x is equal to x squared. All right. So this point right here is C comma C squared because of what the function is. Let's choose another point. This point is the one that I'm going to let go towards that other point. All right. This point here, let's just call these values x comma f of x, which for this purpose with the squaring function is actually represented by x comma x squared. All right, because whatever value is in the first coordinate of the ordered pair, the square of that value will appear in the second coordinate. That's what this means, right? All right, so now let's try to find the slope of the line tangent to the graph at the point C comma f of C, or C comma C squared. Let's go ahead. All right, so the slope of the tangent line then is going to equal the limit as, and what I want is I want this point, this blue point, to get closer and closer to this green point. So I'm going to let the x value of the blue point, which is just x, approach or get closer and closer to the x value of the green point, which is C. So as this x value gets closer to this x value, these 2 points get closer and closer together. All right? And now what I'm going to do is I'm going to look at the slope of the line connecting the green and the blue points. So there's a line of tangency, a secant line connecting the green and blue points. If I take the limit as the 2 points get closer and closer together, I'll get the slope of the tangent line when the distance between them becomes infinitesimally small. So it's going to be x squared minus c squared, or y2 minus y1, divided by x, which is just itself, minus c, or x2 minus x1, minus c. So as you can see, it's just the y value here minus the y value here divided by the x value here minus the x value here, and we take the limit as the two x values get closer together. The limit as the second x value gets closer and closer to the first x value. So we get this here. We can calculate that limit. Well, if we plug c in right away, we get 0 over 0. So what we want to do is we want to go ahead and we want to factor this because we have two polynomials. The numerator of this fraction becomes, it's a difference of squares, so I can factor it as x plus c times x minus c. And this is all still divided by x minus c. Those two factors would cancel out, and I see that this is just the limit as x approaches c of x plus c. And now this limit I calculate by just plugging c in for x. As x approaches c, this just means to plug in c for x, so I get 2 times c. So whatever the value is at my point of tangency, whatever the x value is at the point of tangency, if I want to know the slope of the line tangent to the curve at that point, all I do is multiply that x value by 2. So for instance, at the point 3, 9, at the point where x is equal to 3 and y is equal to 9, the slope of a tangent line to that point on the curve would just be 2 times c, which would be 2 times 3, 6. So there you have it. This is the formula for calculating the slope of a tangent line at any point where x is equal to the value c. So, and c is just arbitrary. So this generalizes the process that we went through in that video.